Hi everyone, I am Amin Harshan Senthil, and today we are moving beyond the implementation to our final synthesis of our Ethermart data strategy. So this is milestone 6, where we finalize our advanced ETL orchestration, implement a robust data governance framework, and perform a comprehensive synthesis of the entire project. This work ensures our data platform is not just functional, but scalable, intelligent, and critically secure. Moving to the next slide. Our project started with a fundamental challenge, that is data chaos. On the left, you can see the initial state. The business was suffering from fragmented data, that is, product information was scattered and inconsistent. So, as Ethermart grew, we hit major scalability issues, leading to slow queries and single points of failure. We also couldn't handle new data like unstructured chat and log data. All of this without proper oversight created serious compliance and risk. So our solution on the right was to build an intelligent infrastructure. This is defined by three things: a hybrid architecture combining MongoDB, MariaDB, and a data lake, integrating AI via vector embeddings for cutting-edge search, and achieving mastery governance with robust ETL pipelines, audit trials, and end-to-end security. We weren't just fixing a database, but we were building a future a proof data ecosystem. Moving to the next slide, the hybrid data architecture. So taking a closer look at the foundation, we successfully transitioned from a monolithic setup to a distributed purpose-built ecosystem. This diagram over here, it illustrates three main pillars. We used a MariaDB Galera cluster, which is a backbone for our core transactional data like orders, products, and all the transactional uh, activities that we are carrying out. The synchronous replication here guarantees high availability and zero downtime. So this is actually used for the integrity. Next, we have MongoDB, which is our flexible data document store. So this is perfect for less structured data or unstructured data like dynamic customer profiles, user preferences, and unstructured chat logs. So this allows us to rapidly iterate on new features like images or audios, etc. Finally, we have the data lake on S3. This is our cost-effective archive for massive volumes of raw telemetry and systems logs. The ETL or data service layer, which we'll discuss next, is the central nervous system that integrates all these data sources into a unified flow. Moving to the next slide, advanced ETL strategy and holistic monitoring. So in this milestone, we focused on making our pipelines truly industrial strength. This goes beyond simple data moving. In ETL orchestration, we are using tools like AWS Glue or Apache Airflow to manage dependencies, ensuring that data flows in the current sequence. So we baked in resilience with automatic retrace for transient failures, and importantly, dead letter queues, which is DLQ, to isolate corrupt records. So what this ensures is like it ensures the bad record does not halt the entire system. So on the monitoring side, our mastery element, we instituted a comprehensive monitoring layer. We monitor system health like MariaDB replication, lag, and resource utilization, and crucially, data quality. We have automated checks for null values, integrity, and consistency across all our data tiers. This unified observability dashboard gives us a holistic view of both the infrastructure and the data integrity itself. Moving to the next slide. This is the ETL workflow visualized. So the key goal here is to uh, walk through all of you guys through the ETL workflow. Uh, this is a visual breakdown of our orchestrated ETL workflow. I like to teach this. It's a three-step process. First is extract, second is transform, and then it is loading. So extract simply means we pull raw complex data from the data lake, that is Amazon S3. So this is kind of our wild data, which is messy and varied, and it may contain structured, unstructured, and different data types. Then the second step is to transform these. So the data flows into the transformation layer handled by a tool like AWS Glue. So this is where the magic or the changes happens. We perform rigorous and data cleansing, validation, and schema enforcement, ensuring the data is reliable and consistent. 1 second. Okay. Data is reliable and consistent, and this step is critical for moving data from a raw, like a data lake, into a structured state. And next is loading. Finally, the clean structured data is loaded into the MariaDB data warehouse, where it is organized into a star schema, ready for high speed analytical queries and BI reporting. The separation of concerns here ensures our transactional database is never slowed down by heavily reporting loads. So moving to the next slide, that is data governance framework. So here, a truly professional data platform requires robust data governance. So we build our framework around four core pillars. The first is the data quality one. So this is nothing but about automating validation tools like a checkpoint to ensure only clean data makes it to the final analytical warehouse. So we need to trust the data we use for decisions. So that is why this step is there in the picture. Like data quality is very important. Second one is stewardship. So we define clear data owners for key domains like products and customers. So if an issue arises, we know exactly who is responsible for data accuracy and solution or resolution. So third one is the protection one. So this is an important one, data protection. So we implement strict personally identifiable information tagging in our data catalog. More importantly, we apply data masking and anonymization when moving data into non-production or analytical environments, thereby reducing the risk. And finally, the last pillar is the management. So we track full data lineage, giving us a complete audit trail from the moment raw data is ingested to the final analytical report. So this is crucial because it is important for troubleshooting and regulatory compliance. Moving to the next slide, that is end-to-end security posture. So this slide covers our mastery level end-to-end security posture. So we tackle security not as an afterthought, but as a core layer. So we have four layers: network, encryption, access, and auditing. So at the network layer, we use VPC segmentation and private subnets. This means no database is directly exposed to the public internet. All communication is happening internally, thereby significantly reducing the risk of attack or reducing the attack surface. Next is encryption. So for encryption, we use AWS KMS for data at rest and mandate TLS or SSL for data in transit. So this guarantees that data protection is there even if the machine is compromised. Next, in terms of access, we enforce role-based access control (RBAC) via centralized IAM, like what you have seen in MariaDB. This adheres to the principle of the least privilege. Only users only access what they absolutely need, eliminating shared credentials. So we'll give a person or a user only those accesses which the user is uh, able to perform, or what all actions that the user is able to do it as a worker. That access only we're giving to the users. And we should eliminate the habit of sharing the credentials as well. So finally, for auditing, we implemented MariaDB's audit plugin and CloudTrail. So this provides a complete forensic record of every connection, every query, and every change, ensuring we can always answer who access what or who have done the changes when addressing these types of risk. So next we are moving to the AI and vector intelligence slide. So here I will be explaining the advanced AI feature built using vector embeddings. So moving into intelligence, we leveraged MariaDB's new vector storage capabilities to move beyond simple keyword matching. So this is our foray into cutting edge AI features. So actually, instead of moving to the keyword matching, we are actually searching for the semantic meaning, which we have already discussed. That is kind of similar to semantic search. So the concept here is very simple. So we use Gemini API to generate vector embeddings, which is like a 768 dimension mathematical representation for all our product descriptions. Uh, for all our product descriptions. Now, instead of searching for the exact phrase, for example, a heavy duty backpack, the user can search for durable travel gear. The system uses semantic search to find products that are conceptually similar. For example, if a person is looking for winter clothes and he's hitting a search button, he should be able to find out all the similar things like winter gloves, winter jackets, winter shoes when he's searching for winter clothes. So that is how semantic search works. So this infrastructure not only improves customer experience immediately, but also prepares us for the future, enabling personalized recommendation engines and advanced AI features. So next, we will be summarizing the main takeaways from the project and outline the next steps for the business. So as we conclude this project, two key areas are important: what we learned and what we go next. So lessons learned were crucial because first we learned the automation is key. So infrastructure as code is not optional, it's essential for managing complexity. Second, security must be first. Uh, that is, giving importance to security features is significantly important. And finally, managers a hybrid architecture requires diverse operational skills and focus monitoring. So these are the lessons that we have learned from this project. So and our future roadmap involves three main goals. It is implementing real-time streaming using Kafka for sub-second data ingestion, achieving automated compliance with self-healing governance boards, and finally integrating our AI ops enable predictive scaling for our Galera clustering based on anticipated traffic patterns. Moving to the next slide. So for this project, a transparent AI usage disclosure is required, and uh, I used tools like Gemini and ChatGPT primarily to draft the boilerplate code and SQL schemas and network designing and Python ETL skeletons. So it acted as a powerful source for me to save my time. And like every time I will ask for a specific code for Gemini or ChatGPT, whichever LLMs which I'm using, they will give me the code, but it won't be correct. So continuous debugging is required, and I have to check whether it's working fine and all the logics are correctly working. So debugging is very key, even though we can get codes from Gemini or ChatGPT, but debugging and human intervention is very crucial. However, the most valuable part was the corrections I had to make. For instance, the AI often proposed hard-coded APIs, IPs, which I had to refine to use scalable security group IDs. So it also missed crucial platform-specific configuration, like the need to manually adjust MariaDB's Galera replication ports. So this taught me the key limitation of AIs, that is, AI lacks deep environmental context and often provides a happy path solution that typically fails in a real world edge cases. So in summary, I would say AI is efficient, but it requires constant architect level verification from human. Final robust security and scalable architecture were achieved through human expertise, refining and correcting the AI suggestions. Thank you so much. This project has been a complete success in building a data platform that is scalable, intelligent, and secure. So thank you guys once again for listening to my presentation. Thank you so much.